This podcast is brought to you by PLI, the Practicing Law Institute. PLI is committed to keeping you ever current on topics that matter to you, like artificial intelligence. Learn more at pli.edu/AIPod.
Welcome to AI and Data Law, part of the PLI Evercurrent podcast. I'm William Tanenbaum, host of the podcast and head of AI and data practice at Moses & Singer in New York. In this series, we bring you the latest perspectives on AI and data through timely talks with thought leaders working at the intersection of AI, data, and the law. In this episode, my guest is Amir Ghavi of Fried Frank. Our topic is large language models in generative AI. In this session, we're going to talk about large language models and then move on to fine-tuning and internal use of those models and variants. And I'm very pleased to have as our guest Amir Ghavi. Amir and I were colleagues at K. Scholler and worked in tech before. And Amir's had a very interesting career arc. So Amir, would you just give us a summary of how you got from your undergraduate degree up to your current position as head of AI at Fried Frank?
Yeah, thanks, Bill. Thanks for having me. And it's good to be chatting again. I started my career, even before I went to law school, I was studying neuroscience and philosophy. And so I'd always been interested in cognition and essentially artificial systems to mimic a human cognition. The problem was once I graduated and went through law school, there really wasn't a lot of work to do in the early aughts around that. So, for those in the audience, I joined Bill at K. Scholler. We did a number of interesting tech things. I was principally, though, a litigator at the time. And really after about 5 or 6 years, frankly, I became increasingly disinterested in litigation. And I focused my practice on transactions. And really, it was high-tech transactions, software. And for me, I was always searching where the entropy was and where the entropy would be. And so I've really made the last 12 or so years of my career around being a disruptive technologies lawyer. And since 2018 or 2019, that's really meant a sharp focus on AI to the point where it is 100% of my practice right now and has been for the past close to 2 years.
Well, that's great. And I know things are going well at the firm, and you've built up some pretty interesting set of clients. So I'd like to kind of leverage your actual experience and help everyone understand first what a large language model is and how it relates to a training set. And basically, let's start with where we are today. We'll move on to where we're going.
Yeah, sure. And my perspective, so those, in the audience understand, is really most of my practice is representing foundation model developers. So these are the large general purpose models that are built, right? A foundation model is essentially a complex deep learning model that's trained on huge amounts of unstructured, unlabeled data that can be used for a multiplicity of purposes, right? You can use it to write a haiku. You can use it to plan a itinerary for a week-long trip to Johannesburg. And you can ask it to generate a lease for, a 2-month term for an apartment on the Upper West Side. It will do all of those things out of the box. And it's a very powerful tool. These really started being developed in 2018, or started being released, I would say. They were developed starting really the 2014, 2015 period by the folks at Google, who actually created the category and much to their chagrin don't get a lot of the credit for developing the technology. But really what you had at the time is the release of TensorFlow, which was a general purpose algorithm which Google had spent a vast amount of resources to build. They open sourced that, which was, from my perspective, a huge gift to the developer community. And then you had an incredible invention, really eureka moment around AI technology, which was the invention of transformer technology in 2017 or 2018.
So I want to take just a break here before we get into transformer tech. Let's take a step back to kind of explore the difference between structured and unstructured data and what unstructured data means in the LLM context as we're using it today?
Yeah, sure. So, if you have structured data, right, this is largely sort of curated, labeled data that will identify, a picture of a dog with the word dog, and you can train those things on the system. You can effectively feed the algorithm, and it will begin to learn based on those labeled and paired data sets. You also have sort of unstructured, unlabeled data, which is kind of more of the jungle, the wild jungle, right? Where you just throw a bunch of data at it and you ask the algorithm to understand the patterns underlying the data. In other words, you throw the algorithm at the data and then you get some sort of result, which, interestingly, I will make another sort of crack at this, which is for those that understand what software is, AI models are effectively the inverse of software. So, what do I mean by that? Software, you start with a set of rules, right? You write code back in the old days. You used to write code longhand, and you have a set of rules that you start with, and then you identify a data set, and you basically throw the rules at the data, and you get an output. AI is effectively the 180-degree flip of that, which is you have this you have this large body of data, you throw an algorithm at it, and then you get the rules. So in many ways, it forces us to rethink the way we've thought of traditional software and technology. And I think what's interesting is, particularly as legal practitioners, a lot of times the way we think is in metaphors. And one of the real cautions, I think, here in this practice area is to not so readily always reach for the metaphors that we've always been using with traditional software or SaaS or other things. I mean, I see any number of agreements that on their face just don't work with AI models and this suite of technology. You can't really just take the SaaS agreement or even worse, sort of the old on-prem license agreement and then just, control F for, substituting some software.
That's great. And let's actually jump into algorithms just for a second to distinguish those from the other tech that's going on. And I'll say parenthetically, people ask me, since I do IP, what's the IP status? Can you patent an algorithm? The answer is you can patent, if they qualify under patent law, the steps that are used by the algorithm. So it's not the algorithm per se, it's the invention, which is the subject matter of a patent, invented in the algorithm, which, as I said, is a series of steps that do that. So, just want to clarify between software and algorithms and then how this ties into the content that gets generated by generative AI. And what you spoke about teaching that cats are cats and cats are not Amir, that's more traditional, what we would call machine learning. Right. And the thrust we're going to get into when we discuss large language models is generative AI. And generative AI is distinguished because it doesn't really look for patterns to the extent it's distinguishable because it generates content. We can talk about whether it's original content or not, but let's just leave that metaphysical question aside for a moment. So where we left off was you talking about how Gen AI makes use of transformative tech. So let's pick that one up again.
Yeah, so really the eureka moment, which ushered in sort of this Cambrian explosion, is around the 2017, 2018 period. A group of researchers at Google decided, well, rather than have these systems try and make literal translations, like maybe we shouldn't try and translate word for word what is going on, and maybe in order to do a translational exercise, right, one language to another, human language to another, we should just take chunks, actually, and segments of the sentence, right? And rather than go so word for word. And what they found was that actually performed much better. It was really somewhat unexpected discovery. And what that led to when people started experimenting was really outsized performance in the way these machines would perform. I'll give an example. So if we look in the old world, right, the pre-transformer world, of translation software, and because we've all been used to things, various translation software that's available, they had a hard time understanding context. And what I mean by that is, if you take two sentences, right? The first sentence being, the animal didn't cross the street because it was too tired. The second sentence, the animal didn't cross the street because it was too wide. The old systems could not discern, in the first example, it was too tired, versus the second example, it was too wide. They couldn't tell whether you're talking about the animal or the street, right? Because they were doing effectively literal translations and some rules-based correction on the back end. The beauty of the transformer technology and what it allowed us to do was to engage in semantic reasoning, right? And we're really beginning to approximate and aim at more precisely the systems of what are thought to be human intelligence. And that all happens through semantic reasoning, right? Understanding what the user wants and returning that. So in this example, post-transformer, you're seeing actual high performance on the ability of the system to discern whether, when you say the animal didn't cross the street because it was too tired, you're talking about the it refers to the animal, right? Because it's understanding the context. And that has been groundbreaking. That allows you to do what you mentioned, Bill, is to generate content, and it generates it in a way which is surprisingly accurate. So let's set aside the notion and controversies of hallucinations, which I think personally are quite a bit overblown. There are a lot of really good mitigation techniques for those. But, the ability to generate content and have it be largely what we want it to be is why this has been such a phenomenon and why it's entered our cultural zeitgeist the way it has. When we first, tried out other voice assisted agents, I'm not going to call, the two out by name, they kind of didn't work, right? Other than giving us the weather or, maybe 50% of the time being able to turn on our lights with a smart system, they couldn't really answer any real questions. This stuff out of the box just worked by and large. And I think that's what's captured everyone's imagination and attention.
Yeah, I can certainly relate to that. And because when I talk to my car to get instructions, it's basically train me to talk car instead of me trying the car to talk me. So you have to fit within certain instructions that it tells you mean something. So if you say, take me home, as opposed to navigate me home, you're going to get a better answer. And since we're tech lawyers, we can't get too far without using acronyms. So I'm guessing that the T is related to the GPT in ChatGPT. And we all kind of move on and forget what the acronyms stand for, but I can't resist. GPT means
generative pre-trained transformer. In other words, it is the model that you are interacting with, and that's called inference, right? So the model you're interacting with has been pre-trained already on this enormous quantum of data. And when we talk, big data, right, back of 5 or 10 years ago, we were always talking about like data contained in these databases. And the databases could be big and they could be really big. What we're talking about here is logarithmically higher than that. We're talking about basically the entire corpus of the public internet that these systems have been trained on. So when we say pre-trained transformer, we look at GPT-4, for example, right? It is an enormous model that has been trained on effectively all of the public internet plus some. You'll have to ask OpenAI.
That will become a rhetorical question rather than an actual question, I'm sure.
Yeah.
So let's have you address a little bit where we are with ChatGPT, OpenAI, and the current large language models.
Yeah, I think, where we are is that we have these general purpose models that companies by and large are trying to understand and experiment with. So there's a suite of them. The leading models right now, you have GPT-4 from OpenAI, you have Claude 2 from Anthropic, you have Coral from Cohere, you have Llama 2 from Meta, Mistral, Falcon, 180B. You have a number of models. And the way I think about these models is they're like cars. Each one has their own set of characteristics and personalities. And so when I talk to clients and, who are corporations trying to understand and use generative AI in their enterprise, I try and encourage them to think about AI models or generative AI as more than just a singular app. Because, GPT-4 will perform very well in a number of characteristics, but it will perform less well than, let's say, Claude 2 in others. And so what all of these models, though, tend to underperform is, not surprisingly, out of the box, they don't tend to be really great at hyper-specific domain-specific tasks within an organization. What do I mean by that? I mean, each company, and when you talk about especially large enterprises, they all have their own parlance, they all have their own lingo, right? Each company has its own jargon. And one thing you can do to make these systems particularly powerful is you can train them. It's called effectively fine tuning. You can fine tune them on your own data sets so that you have this base model, this GPT, which is then out of the box pretty effective. But then you train it on your own endogenous data or exogenous, whichever. You can bring in external data, or you can give it internal only data. But then it really can speak the lingua franca of your organization, but also will really know your business and industry particularly well. I give an example. There's you look at MedPalm, for example, from Google, right? It takes a general GPT data set and a general model, and then really fine tunes it on medical data, medical information. And the results are astounding when you compare the two in terms of its ability to answer medical specific information. There have been other studies done. Yale School of Medicine has also, I believe it was their neurology department, fine tuned on a corpus of neurology information. And there actually gives a rather impressive set of results as compared to the baseline.
So I want to dive a little deeper into that. So we're fine tuning an it. What's the it?
Right.
And then what does fine tuning mean, either in tech talk or English?
Yeah.
Or both?
Yeah. So when you're fine tuning the model, you're basically taking the model out of the box and you're changing some of the parameters called weights.
And how do you get the it, and how do you define the box?
So good question. So if you're using one of the vended solutions, they effectively have to give you access to the model to be able to change the weights, change the parameters in order to fine tune on your data set. You can go an alternate route, which is you can use one of the number of open source models, which include the Llama 2 model from Meta, the Falcon model from TII, the Stable LLM is a publicly available open source. You can take those which out of the box give you the ability to adjust the weights. There are a number of different techniques. I don't want to go too deep down the rabbit hole, but the basic idea is you want to strike the right balance between retraining certain elements of the existing model on your new data, but not retraining so much of it that you've broken what was pre-trained, if that makes sense. Part of this experimental process is, you've had some groups which have been really zealous about trying to get better data and get hyper specific to their data set, but they end up breaking the model to begin with, and the net result is quite poor performance.
So how does the training work when the enterprise is doing it, as opposed to either the open source software or if it's coming from a vendor? Who does the training, and what are the legal issues that surround the training?
Yeah, so you have to have a group of rather specialized personnel to really tackle this problem. You need a couple of things. You need access to compute power. So you need one of the hyperscale cloud providers. So that's really Azure, AWS, Oracle, Google Cloud Services. Then there's some others. Databricks and Snowflake offer their own sort of solutions, but you need access to compute. And what you do is you take the model. Let's use the open source example, although in reality, this doesn't differ that much from the vended solutions. But you take the model as is, and you're given access and ability to change some of the weights. Now, what are you going to change? You're going to change those based on the new data that you're feeding it. Remember, these models and the algorithms are essentially learning systems. So what you're doing is you're taking, I'm going to use some metaphors here, you're taking a hungry learner and you're giving it some fodder. You're giving it a new set of data, and you're saying, okay, you are trained to do this certain thing today. Be hyper-focused on this new training data that I'm giving you. Be more specialized. So obviously the first step in that is you have to find the new set of data that you want to train on. And you can look internally, you can look externally, but that in and of itself can be quite a task, is to find the right corpus of new training data. And I know in your career, you've been wrangling data for decades. And maybe you can share some experiences with how that's actually a shockingly difficult task within an enterprise.
It is, even when you're doing something where you're in a field like financial services or healthcare, where it's not actually a natural language, right? The words that doctors use are, derived from some Latin something or other, but the advantage is that they all use the same something or other. So that makes it easier to kind of process that.
Right.
And, in fine tuning, what you want to do is you want to say, I want my employees to be able to do certain prompts that are get a reliable outcome. And I want it to be able to do the tasks that my enterprise does on a day-to-day basis.
Right. So basically, once you identify this corpus of high quality relevant data, then you've got to decide, well, which model you want to train it on. And that's not an insignificant decision. Some of the general purpose models can be very big, means they're very powerful. They do a lot of things well. That doesn't come without a cost, though, right? In that world, if you tend to train and run on an inference, which means use these large multi-purpose models, it's great until you get your cloud compute bill at the end of the month, which can be shockingly high. This has caused a lot of people in the enterprise to look towards smaller models. And so what you're starting to see is people are trying to get to effectively the concept of MVP, like a minimum viable product. It's like an MVM. It's like the minimum viable model. What's the smallest model we can get away with using that will do the task at hand, right? If we're not writing haikus, or we're not, creating instructions to build a skyscraper, or we're not, explaining, itself, right? If we're not trying to do all of these things at once and we want a rather narrow business task, well, maybe you don't need, a 500 billion parameter model. Maybe you can do with a 7 billion parameter model, which means that you effectively your cost at the pump, so to speak, here being the cloud service provider, your cost to run these systems will be drastically reduced. And I think that's what, now when I feel like we're in, I wouldn't call it version 2.0, but we're in a subsequent phase of experimentation. The first phase was everyone took the popular application. People were experimenting with GPT-4 in an Azure environment. I think right now people are trying to experiment with whether they can get to their minimum viable product or proof of concept internally using alternate models that may cost less within their vended cloud center. And so that's a really big decision to make. It's a big decision to make because not all of the models share the same license. And so, Llama 2, for example, it allows for commercial use, but it doesn't allow for use if you have more than 700 million monthly active users. That probably doesn't apply to a lot of companies, but also you have a prohibition against training non-Llama models on the outputs of the Llama system. In other words, if you're trying to train a model on synthetic data that you generated from model A, you can't transpose it across to, a model that's created by someone other than Meta in that example. Each model tends to have its own bespoke license, unfortunately. I think the industry is trying to focus around and coalesce around a common license. So far, I would give the AI industry a D- in coalescing around a single license, because everyone is coming out with their bespoke licenses. And it's caused, frankly, massive confusion within the adoption sphere.
So that raises a whole point of issue that we're going to put to the side, which is how do you take these licenses and what do you do with them? And since you can't do a lot with them, what do you do when you can't do a lot?
Yeah, I mean, I think it's all about it's still experimentation. I think people, well, there are two things happening. This is not happening in a bubble, so to speak, which is that the developers of these systems are also listening. They're hearing feedback from people like me and others that say, okay, well, the reason enterprises won't use it is because they're used to traditional licensing terms. They're used to things like an indemnity. And I think we've seen, for example, at least in the vended space, we've seen the concept of indemnities effectively become standard practice with large language models. This was not the case 6 months ago. And so there's been a learning process whereby the vendors are now hearing the customers. And if these use cases are going to be realized, I think both sides are going to have to hear each other a little bit better.
And how's that dynamic work between the enterprise and the LLM vendor?
So,
as a process point of view, as opposed to an endpoint.
I would say right now there's not a lot of dialogue by and large because the large language model developers are still mostly research institutions. They are not traditionally enterprise software companies that are used to selling en masse and educating. They've built this new technology, they make it available, and they're still growing into their role of being an enterprise software provider. So I think it's one of the reasons you saw, if we were to graph it, right, when OpenAI released this technology, I think there was a rather tepid actual engagement and response. There's a lot of excitement. But the reality was, to your point, people didn't know how to connect the dots. It took until Microsoft basically embedded OpenAI into Azure and offered it as a set of tools available through the Azure contract and the master Microsoft services agreement. When that happened, you saw almost universal experimentation because you didn't really have to do anything different. Every major enterprise in the country is a Microsoft licensee, and you suddenly had the ability to experiment with these tools in a sandbox. And then it became an exercise, a diligence exercise of, well, do we have the basic security considerations taken care of? Do we have the indemnity taken care of? How do we think about IP? I don't want to sort of distract the topic of this with those points, but I think there was a box checking exercise that I think people got through, and now they're playing with it and figuring out use cases, and they're getting the cloud compute bill and they're deciding whether they have to re-engineer or rethink their use cases. People are experimenting.
So I want to go on a sidetrack for just a little bit and ask you what you're seeing and the warranties that are offered and how they've changed over time.
Yeah, I mean, they didn't exist to be, well, right now I would say the warranties are nil. What you're seeing are indemnities, and the market has basically, the market meaning from the large language model developer or vended large language models, they've realized that the standard for a software vendor is to offer an indemnity.
Against what?
Against use. In most cases, it is for IP infringement and use by the users absent sort of a manifest intentional intention or intentional attempt to elicit an infringing response from the model. Which is to say, if you're using it as intended, generally, you will be indemnified. But if you start to put in a paragraph or 2-paragraph long prompt filled with a bunch of specific trademarks and protected IP that you're trying to essentially get the model to recreate, you're not going to be covered.
Great. Okay, so now let's move a little bit more into where the leading enterprises are going for internal use and how they're using plugins and what will really make it version 2.0.
I think the use case, I'll talk about the use case that a lot of people are experimenting with as a proof of concept. Then I'll talk about my favorite use case actually within an enterprise. A lot of people they feel like the low-hanging fruit are chatbots and chat windows for customer service applications. That is to say, and this comes in two flavors. There's a mild and then there's like a more aggressive version. The mild version is it just sits in the background and it will merely summarize the session it'll merely summarize the session with between the user and the company. That task saves about 5 minutes of the customer service agent's time. That's the mild version. The more aggressive version, and there's kind of a spectrum here, you can have it sit, metaphorically on the shoulder of the customer service agent and offer suggestions in real time. Or if there's a language barrier on the other side, it can do real time translations. These are massively powerful things that work essentially out of the box. So it's good for upselling, it's good for being specialized and bespoke to language. And then you can sort of ramp that up even another level, which is you effectively have the agent doing the primary interaction and you have the human just watching and guiding and making sure nothing goes off the rails. I think it's a massively exciting and powerful application. The enterprises are deciding what's right for them. That is, I think, in terms of numbers, what we're seeing most in terms of low-hanging fruit, easy to use adoption. A large language model is basically just a technology for semantic reasoning. It understands and can work on a very bespoke level, a tailored one-on-one level with your user. What are instruction manuals? They're these generalized rules, explanations that are rather static, and all of us in our many different ways of learning, some are visual learners, some are auditory, we all learn in different ways, different speeds. We're all expected to sort of figure out how to build this bookshelf or build this table or install this router based on this one set of static instructions. I think the best use case right now for LLMs is making instruction manuals truly interactive and bespoke to the level of the user. You can have an LLM effectively out of the box, train it down to the level of even an elementary school user, right? And you can ratchet it up to a PhD level user. And I think that, to me, feels very powerful. I think it also, you can see the way it would transform learning, knowledge management, even within the enterprise. And there are some really great studies. There's a study from a professor at Stanford, Eric Brunjelson, who did a study where there was an almost immediate 14% productivity increase by giving customer service agents access to large language models. There's been a more recent Boston Consulting Group and Harvard Business Review study where if you give this large language model technology to knowledge workers, so rather on the higher end of the scale in terms of value, you see not only quantitative but qualitative increases in the work, 40% increases in the quality of the work, and 20-something% increases in how quickly the work is being done. So, the ability of these systems to understand the user and then give them back what they truly are asking for, rather than, to your point, learning to speak car or learning to speak some sort of third, language, is really what makes these things so exciting.
So this, I think, is what's going to take us to version 2, where the enterprise can use this for its specific type of business, and then the tasks within that type of business, and then the tasks associated with the sophistication of the work that the knowledge workers are doing. I mean, that's where I see the excitement, and that's where I see the enterprises see the value.
Yeah, you get to truly unlock it's been 20 years where we've been talking about big data and all of the promises. And sure, I don't mean to demean the study of, statistics, but we've had statisticians and data scientists, which have done some pretty interesting things. But by and large, a company's data still feels pretty locked and untapped. And I think this really allows people to realize the value of their unique data sets in a completely different way than what was possible even 2 or 3 years ago. That's the excitement. I'm working with a number of large, Fortune 250 companies that are looking internally at their data and wondering, it's almost an existential question. Now they're kind of wondering, what kind of company are they, right? They may have been building widgets for a long time, but now they have a lot of information about the widget building and selling and process. And now they're thinking, well, wait, if I can use all of this huge volume of institutional knowledge and data, am I still in the widget building business? I think it really is a game changer. I mean, let's just look at the pandemic as well, to give another example that I really like. I like it for maintaining institutional knowledge. We've seen, people no longer stay at the companies for 30 years anymore, right? And a lot of that knowledge walks out the door when someone changes jobs. Well, with large language models and the ability of these systems to really understand and to sort of keep this corpus of information, you don't have as much data leakage from people anymore as you used to.
So this has been really interesting, and we're going to wrap up soon. But I want to talk about what a hallucination is and why there's going to be less.
Yeah, so hallucination, I kind of smirk. It's, the neuroscientist in me is annoyed because hallucination is a term, but we're using the wrong metaphor. It's actually a confabulation. It's the classic definition of a confabulation, actually, which is it is a technically inaccurate result. So it is a result that is not true, but that the person that's or system that is putting forth that statement genuinely believes it to be true. And so this is what makes this phenomenon challenging in the context. And we've seen examples where there's a radio talk show host in Georgia that's sued for defamation because a reporter had asked ChatGPT about this radio show personality, and it said that he had embezzled money from a nonprofit before, right? So it's this classic example of the system affirmatively making a statement, but not telling you that A, it's false, or that it's even unsure. So when these large language models give you a result, it's flat in the sense that all statements are given without qualification of, well, I'm not really sure, but I'm going to guess, right? That doesn't really happen. Now, how do you mitigate this? There are a number of techniques. The first.
So let's stop you right now. So now we're talking about AI is really as a toddler at this point, right? It's learning a language, it's repeating what it hears, and it's confusing, bad weather with food. And so you get these strange things from a little kid, and you can kind of figure them out, and you can kind of see how the kid got to them. But I think we're moving to the point where we're moving from toddlers to at least some other level of language comprehension.
Yeah, and I want to correct one thing in your metaphor. I don't think they repeat what it hears. These are not stochastic parrots. They begin to the extent that they give us results and responses that are cogent. It's not because they're mimicking something in their training data set. It's because, again, by the volume of the data that they've trained on, they emulate the ways in which we communicate. And I think that's what really is exciting about this.
This sounds like the neuroscientist in you coming out.
It is.
Well, go further. I didn't mean to interrupt you.
Yeah, no, I think that's what's powerful. And I think I know that the foundation model developers are increasingly focused on mitigating hallucinations. There are a number of techniques, even within the enterprise, right? As you train and fine tune on more specific data sets, observed hallucination or confabulation rates drop. You can also implement a number of other techniques, one of which is retrieval augmented generation, which is you basically, can tie in information in a data set without changing the AI model and system itself. So basically, it has a referent to go to rather than constantly generating things on its own. There are a number of techniques that really drastically reduce this phenomenon of hallucination / confabulation. My prediction is with GPT-5 and Claude 3 and the next version of Coral and these really serious foundation models, I think we're going to see hallucination rates significantly drop.
Well, that's great. So it would be terrific to end this on the point of hallucinations. I think that's remarkably appropriate. So I want to thank you. This has been really great. And we're going to have you back again to keep going.
Thank you.
See what V2 looks like. And I think as we both agree, the enterprise fine-tuning is the future. And that's where we really have to focus. You might not like toddler, but getting away from toddlers and getting away to fine-tune children, I think is going to be a lot better.
Yeah, to take your metaphor, it's taking the capacity to learn of a toddler and giving it a 301 level textbook, and afterwards it reasonably understands and digests that textbook, and that just gives you a whole new solution set and a really powerful technology to run your business. I think the next wave of potentially interesting technology involves a departure from the GPT or the generally pre-trained transformer and moving away from transformer technology because there are inherent limitations as to what it can do. There are some really smart researchers who are working on a totally new paradigm of non-transformer based AI, and they think there's some early promise. There's a really long way to go, but I think we will begin to see teasers of what those results are probably in the spring to early summer of 24, and that'll be fascinating because it is a completely different style of technology, all the while being firmly AI.
Yeah, the point I want to emphasize is there's not a uniform technology out there in the world when we say generative AI. And you have different companies taking different approaches to the data, to the algorithms, and to all the other variables. So I think it's important to recognize that, this is the Cambrian period. There's a lot of change going on here. And it's just important to recognize that you make choices when you pick certain large language models.
I think it's right. It's important to understand really that AI and generative AI is not an app, it's a technology, right? And within that technology, there are a number of different providers. And to go back to my car analogy, you don't walk into a dealership and say, I would like a mode of transportation. You walk in and you want a convertible, or you want an SUV, or you want a pickup truck, or you want a van, right? Each one is tied to a specific use case. And I think that's what we're beginning to see, is that people are getting a little bit more sophisticated about models and model selection. So they're going into the dealership and they're saying, well, I need something to move 10 to 15 people. Well, okay, that is one solution set, as opposed to, I really like to take, sharp turns at 35 miles an hour. That is a very different, solution. So.
Terrific. Well, we've now moved from GPT to back to cars and having cars train you. And now we're talking about picking the right car so you can train it. Well, really, thanks again. I think we've all benefited from the fact that you're working with such high-level companies at the kind of cutting edge as technology as it develops. So this has been terrific. On behalf of myself, thank you. On behalf of the rest of the audience, thank you for explaining some of the acronyms. And it's just wonderful to have you on the show. So thanks very much.
I appreciate it. I've had a lot of fun, Bill. Thanks.
Thanks for listening to AI and Data Law, part of the PLI Evercurrent podcast. Please note that the views and opinions expressed in this podcast represent those of the host and individuals being interviewed, and not necessarily those of PLI. For more AI-related content from the Practicing Law Institute, visit pli.edu/AIPod.